could someone just unmute yourself and confirm once if I'm audible?
Yes, sir, you are audible.
Nice. Thank you. Thank you, Yash. So before we start, how are you guys doing? How are you all? Excited for the bootcamp?
Yeah, sure.
Yeah. So Yash, since we are already conversing, what I just wanted to know, what are your expectations out of this webinar? What do you expect to learn out of this, bootcamp?
Not only of the steering part, but everything about Hummer.
Okay. Good. Good aim. I think you should explore more about automotive if you're interested in it. Anybody else would like to talk about it? What are your expectations out of this bootcamp? Jayana, you had unmuted yourself a while back.
Yeah, nice. I think it is a good series what you are doing. Really, what is happening inside
This call is now being recorded.
new development, what is going on.
Mm-hmm.
One should be definitely get acquainted and get to know, because many things we only read through some magazines and things. Best is to interact and have a interactive sessions like this. Probably you have to ask us and check our knowledge level and understanding level, so that we can also try to put efforts in going through this.
That's actually very well put. Like you
Another
said,
thing is you use some different terminology. I don't know this today's topic. You said, what is exactly that?
it's the crab walk in Hummer SUV. So basically, like you
Wow.
said,
See, sometimes these words are definitely new for automotive sectors, and particularly maybe for me. I am an aged person with not much acquainted with the latest terminology, but it's a good day. I think your way of dealing is really, I appreciate Arbaz. Nice way of interaction, making people to understand.
that's really great to hear. Thank you, Jayana. That's very well put. Like you said, you will be explaining the technology that is being out that usually we used to know by reading the magazines.
I think there is a disturbance once the people started recording.
Yeah, there's like disturbance and it's going on as well.
Not audible now.
You just stop recording and say something, then only we'll know.
I think you may have to stop recording.
Stop the recording part, yeah.
To you guys.
Your voice is somewhat breaking. Sir.
Your voice is breaking.
Not audible.
I think now it's correct.
I'm audible to you guys now.
Yeah, the disturbance has.
Are you somewhere nearby some making units?
Hello. Voice is not being just a little bit. Am I audible now? Is it clear now?
No. I think something to do with your recording system. Pick up now. Maybe let us see. No, we are not hearing you.
You are sounding like a robot. You can understand what kind of sound it is.
Some alien sound is waiting. Sir.
Okay, am I audible now?
Yes.
Is it clear?
No, it's not clear, sorry.
And
Still
before
it
the
is like
recording, it was clear. Yeah? Before the recording,
Now it's okay. Now it's
now
okay.
it's okay.
now it's clear. Okay. For everybody, I'm audible to everybody. Please let me know.
Yes,
Yes,
yes.
it's
Please start.
Cool. Okay. So now my voice is clear. It's not robotic. It's not. It doesn't have any disturbance, right?
Yeah. Yes.
All right. That's good. Yeah. So few people have raised their hand. Let me know if you guys wanted to talk about something before we start. Okay. Anyways, so moving on, like Jana said, it's very, the new technologies nowadays are very difficult to understand and difficult to know because of the, the words, the terminology they use, and they're far from the basic. So what I'm going to do here today is I'm going to take an advanced technology which is used in Hummer SUV, which is called the crab walk, and I'm going to try to explain to you guys in a basic manner. I'll take you through the most basic thing that you need to understand the Hummer crab walk, and I'll start from there and probably give you a good understanding about how the crab walk actually works, right? So today's session is on crab walk. Let me actually share my screen before doing anything else. Yeah. Please let me know if my screen is visible to you guys.
Yes.
All right. Yeah. So like I said, we'll be talking about crab walk. So funnily enough, I found a good picture of crab. So actually, just for the fun of it, before we start with the technical topic, let's get comfortable with everybody. I've already spoken to a few of you, but most of you are still silent. So I would like to ask you guys, like, what do you call crab in your language? What do you, say? What do you call crab in your language, basically?
Kekada.
Ikra. Anything else? That's a common one, I guess.
In Kannada, we call as a.
Bichu.
Huh?
Karnataka.
Yeah. In Kannada, we call as a. What is that?
AD.
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 AD
Nice.
in Karnataka, Shivamogga and all.
Denji
They
in
are
Tulu.
They are
Tulu, it's
available,
Denji.
but nowadays it is not very tasty. Those days, about 20 years back, they were really tasty.
Yeah, that's good to know. That's good to know. All right. So yeah, good old days, tasty crabs. I can understand.
Yes.
Yes. So moving on, let's see what actually crab walk is. Right, it was an interesting moment we had. Now let's see what actually crab walk is. So recently, not very recent, I guess, a year back, I guess, Hummer released their electric SUVs. And as a mechanical engineer, I am more inclined towards looking on the internal parts of the vehicle, what they have done to bring up the new technology. And this was something that caught my attention. Okay, so this is the motion that they have achieved, right? So they are moving the vehicle in the diagonal manner somehow, right? And this is basically the crab walk, and the applications of this and the possibilities through which you can use this in your regular life are endless. Like once you get used to it, of course. So why how was this made, and why or how this works? That's what we're going to explore today. So as you can see, like I said, all the vehicle actually moves in a diagonal manner. As you can see, the vehicle is pointing towards the front, but its motion is on the front and side as well, producing this diagonal motion, right? So let's see how exactly this works, right? So if I let me just start my pen over here. Yeah. Okay, so what is happening exactly over here to understand what is crab walk for everybody, right? So let's say if you have your car in the shape of this box, right? And this is the front, right? Actually, let me change the color so that it's better to understand. Yeah. And usually, if you want to get from point A to point B, you have to follow a curvature, right? It could be if you want to get to a point, let's say over here, right? You will have to follow a curvature. You'll have to probably go like this, right? Something like this. It would be, and then you'd be at this point in this position, and your car will be facing still forward, right? To give you a better example, if I scale this all down a little bit, right? So let's say the green part is actually your car, right? And let me select red over here. The red part is an obstacle or a car in front of you in traffic. And let's say if you want to overtake it, right? It's not an ideal example, but let's say if this is the case, you want to be here, right? So the blue position is where you want to be, right? So your typical option, right? Actually, let me change the color once again. And okay, so your typical option would be going like this, right? Going like this and then getting in this position and then moving forward from here. And then maybe if you want, you can go over here as well. So that's the, general approach that we used for so many years in automotive. This is how we turn, this is how we move. But with the crab walk technology, what Hummer SUV has done, I don't know if you can see yellow on the screen. Yeah, it's visible. So what they have done is instead of asking you to go in this curvature, they have given you the power to move diagonally like this, okay, in this direction. So basically your whole vehicle will still be pointing at front at all time while you move. And that's what we are seeing in this video. If I play the video once again. So basically you can see the whole vehicle is moving in the right directions, following the yellow line. Your voice is breaking once again.
Even your voice is getting disturbed, Sheikh.
Hello, my voice now.
Not audible.
Okay, actually, let me check and okay. Let me change my earphones and see if that works.
Your voice is breaking, sir.
Okay. Okay, am I audible now?
Yes.
Is it clear?
Yes, sir.
Nice.
Yes, sir.
I guess it's way better than before. All right. Okay. So moving on. So like I said, I was saying that this is the motion that we have. It's going to move in the diagonal direction. It's not going to follow a curvature and then go in that direction. And that's what actually we see in this video as well. And you can see that how this can be applicable, right? How this can be applicable. So if I move this video a bit forward towards the end of it, you'll see it's the vehicle is parked in a difficult situation, right? And what the driver has to do is simply turn on the grab walk a little bit in the reverse direction, and then the car is free to go in this direction. And that's as simple as doing a motion with your body itself. You don't have to turn your body like you have to turn your car, right? And that's the freedom that the Hummer SUV has provided with this grab walk technology, right? So before I move forward, I would like to ask you guys, what do you think would be an application of this grab walk technology for you personally? What would you do if you have this technology?
Maybe from the safety point of view and also racing cars, I really doubtful racing car, but definitely from the safety point of view, this will definitely, but I don't know how vehicle will be stable because it has to be through wheels only. The
Correct.
wheel has to move forward and also sideways. I don't know what type of motion you give to wheels for moving sideways.
Correct. So interestingly enough, that's what actually we are going to discuss, right? Interestingly enough, if you think about it, every time you're going forward, right, you are overcoming the frictional force that is coming to your wheel, right? If I'm clear to you, I don't know if you're getting my point, but every time you're moving forward, even when you're walking, you're overcoming the frictional force between your feet and the ground, right? here in this case, if you're walking diagonally, now imagine yourself walking diagonally, right? Your balance would tip a little bit and your feet would still remain as it is, right? And that's the important point over here, right? Actually, before going to that, let me tell you how this works, okay? So to understand how the wheels of it rotate and how it can be, it can be done in any type of car or by anybody, we'll first need to learn how currently the steering works, right? So in most of the vehicles you see on the road, all of them follow, like most of them follow Ackermann geometry, and this is what a typical Ackermann geometry looks like. So here you see actually, yeah. So at this point, you see there's a center of turning circle, right? It's called instantaneous center. What it actually means is when the vehicle is going to turn in this direction, it is going to rotate in a circle. If I draw a circle like this, somewhat like this, actually, sorry, I got the circle wrong. Yeah, but if I draw a circle to follow the path of my vehicle, it would probably look something like this, right? Something like this, and it will end up back here. And the center of this circle is what we call the instantaneous center, right? So here on the screen, the entire vehicle will actually follow a circle, a big circle, and the center of that circle will be this center. Okay, this center, the circle would look something like this. The red lines that are there. Of course, my screen is limited to show that, but in the later slide, I'll show how this works, right? So basically, what this center is, it's a center of the circle that a vehicle makes while it makes a turn, right? Even if it's not going in circle, it still has to follow a center. Now, anytime a vehicle turns, right, there's always going to be an instantaneous center, and it is called an instantaneous center. Let me write that down. Instantaneous center, right? Because it's only for that instant. It changes constantly. It will not remain constant all the time, right? This is the instantaneous center, and it will not remain. It will not remain constant throughout, right? It's going to change at every given instance. The reason behind that is the when you're steering, right? When you're steering, you're turning your steering wheel. Your wheels are going to not turn directly in this direction, right? So let's say if they are in this manner right now, right? In the initial condition, they're pointing forward, right? And if you want to turn them, you want to get into this position, the green position, which I'm about to draw, is this position, right? You want to get them into this position. So going from the red to green, they're gradually going to turn. They're not going to turn instantaneously, right? They're gradually going to turn. And because of this, the instantaneous center is going to start from somewhere around here and then come to this point over here, right? It's going to move. And that's why it constantly changes every instant. And that is why it is called an instantaneous center, right? Now, with that said, we always need an instantaneous center to turn our vehicle, right? And in this condition that you see on the screen, this condition is called a perfect rolling. Okay, a perfect rolling. What does this mean is we achieve the perfect rolling because the front wheel, right, and the front wheels rather are turned at a very perfect angle. Both the front wheels are turning at a different angle. If you see over here, the inner wheel is turned slightly higher than the outer wheel. So what we call an inner wheel, since we're making a left turn, this wheel will be inner wheel, right? And this wheel is slightly turned higher than the outer wheel. Over here, you can see the turning angle is higher than this one, right? Now, this is done to ensure that the axis of these two wheels collide at a point, right, which lies on the rear axle. So if you extend, what this actually means is, if you take a vehicle, okay, let's say if I, let me first erase everything on the screen, yeah. So if I take the four wheels, right, if I make a vehicle sort of like this, right, and if I draw, and this is the rear axle, this is the front, over here we got the front axle, and of course this is the front side, okay? And if we extend the rear axle over here on the side, right, I want to turn my front wheels in a way that I would get the instantaneous center on this line, on this extension, over here, anywhere over here. As long as this is over here, right, as long as it's on this line, it will give me a perfect rolling, which means if I turn my wheels in this manner, if I do this in red color, so now basically the turned wheels are shown in red color. If I turn my wheels in this manner, right over here, the instantaneous center will meet on the extended rear axle, and that will give me the perfect rolling. Okay, Now, what is perfect rolling? Perfect rolling is on this line, all the wheels, it will give you perfect rolling, which means there is no slip. If I turn my wheel is rotating, every wheel is forward in this red color rotation, right? There is no slip in it. If you think about it, if this does not happen, you can think of drifting. The extreme example of this would be drifting. If you're familiar with it, you must have seen vehicles, drift. In that case, the wheels are not rotating in the same direction as the vehicle is going in, right? So here, perfect rolling happens when the vehicle is going in the direction of the wheels. That wheels are pointing in some direction and they're rolling in some direction, and that's where the vehicle is going, or that's where that particular wheel is going, and that's called the perfect rolling. Now, this perfect rolling can be achieved by one method, which is keeping a instantaneous center, which is common for all wheels. One method of doing that is using Ackermann geometry by getting the instantaneous center on the extended rear axle. Okay, this is one method. Now, just for the sake of understanding crab walk, first we need to understand the Ackermann steering geometry and the purpose of instantaneous center and the purpose of why these two wheels, extended lines of these two wheels meet at the rear wheel. So if anybody has any doubt till now for what I have explained, please let me know. Actually, if you have a problem unmuting your mic, you can also, put your doubts in the chat box, right? And I will try to answer them. But I prefer talking to people, so please, if you can unmute, please go ahead.
But whatever you say, this change in this instantaneous circle, is it within a fraction of a second? Sometimes it may be a bit unimaginable thing. How you said there should not be any slip. It should be only rolling.
Yeah, that's the ideal condition. It's not like it's all the time it's going to be perfect rolling. Ideal condition, we want there to be a perfect rolling. Amarjit, what do you mean by in off-road conditions? Would you like to elaborate on that, please?
Which one?
Amarjit has texted in the chat box. That's what I was addressing. Okay, are there no more doubts? Like I want to continue, but before that, I do want to solve your doubt if there are any. So please let me know if there are any doubts.
I think this may not be required for a off-road condition. I don't know. Off-road condition means it is in the hilly region or where we have not a smooth or roads and terrains.
Correct. So it would not be required, though it will be kind of, a good thing to have. Clifford was saying that this might be helpful during parking. Definitely the grab walk would be helpful during parking because you can get into tighter spots and do that easily with very less time. Amarjit, could you explain to me what exactly you're asking in off-road condition? What do you mean in off-road condition? What exactly do you want to say that this application can be used in off-road condition? Is that so? Okay. So yeah, definitely. Even in off-road conditions, the grab walk can be used because see, we cannot be sure what comes in the off-road condition, right? Because you may come across a target. Like basically, if you see this video that Hummer has released, that's actually what they are doing. They are going into off-road condition. This is not a perfect road. They are going into off-road condition. They have these obstacles. They have these wooden things pointing out. They have rocks over there, and that's what they are doing. So definitely in off-road condition, this would help. And also, if I'm not wrong, in this video, no, not in this video, but if you watch videos of this, you'll definitely see that Hummer SUV is designed to go into the off-road condition. Yes, definitely, system can be used in heavy traffics as well. So anywhere you think there is the requirement of squeezing your vehicle into a tight spot, that's where you can use the grab walk. Okay, if anybody has a doubt regarding the Ackermann steering geometry, please do ask because it's going to be really essential for the upcoming slides. Okay, I think there are no doubts regarding. Okay, very good question, Kaustubh. Why is it not used in normal cars, right? And like it's like it should be used in normal cars. Why is it not used? It would be a good thing to have for everybody. So, Kaustubh, first of all, counter your question, basically, when we use crab walk in any car, it's going to be expensive. Okay, and it's going to create a lot more complications when it comes to a drivetrain, when it comes to the rest of the parts of the vehicle, basically. And that is something that you can do in a big vehicle. Point number one, and you can do in an expensive vehicle, right? And both of them being the Hummer SUV. It's big and it's super expensive, so that's why it is used first time in Hummer SUV. Although it will be useful in normal cars as well, the cars you see on the road, the passenger vehicle, what we call it. Okay, are there any more doubts by anybody? Please let me know. Okay, now that everybody is clear on the Ackermann geometry, we can move on to the next thing. Okay, so now let's see from here, right, how the Hummer SUV turns. Okay, and it has got something what we call a 4-wheel steering system. Okay, and as the name suggests, can anybody tell me what exactly the 4-wheel steering system would mean, or what would it do, just by logic, but just by hearing the words?
All the wheels are turning by some degree or something.
Correct. So basically, you provide steering motion to all the wheels, not just the front wheel, but also the rear wheel. And this can be helpful. Now, how that works is, let's say if I have one vehicle, okay, let's draw the same thing again, what we had in the previous slide, right? So I have the front wheels over here, the rear wheels over here, and for now they are in the straight position. Let's say if I want to turn towards the left direction, like this, right? What I can do is I can turn my front wheels like this, right? This will be the axle, and the other wheel will be turned like this. And for the rear wheels, what I can do is I can either keep them straight so that this extended line meets the extended line of my rear wheel, or else what I can do is, instead of doing this, actually let me erase the dotted lines. What I can do is I can turn my rear wheels in the opposite direction of my front wheel. Okay, what I mean by that is if I have if I move the rear wheels in this direction, like this, right? If my front wheels are moving towards the left, I'll turn my rear wheels towards the right direction, right? And this being the rear axle. Now, if you think about it, instead of getting the instantaneous center over here, which is on the extended line, right? Instead of it coming over there, now the instantaneous center will be somewhere around here. And the lines from the wheels will be coming out like this, right? So essentially what we are doing right now is we are reducing the turning radius. Okay, so as you can see in the previous slide, what we had done was we had turned the front wheel so that you get an instantaneous center on the rear axle extension, right? Now what we have done, so basically why this happens is because, why we wanted to do this, to get the perfect rolling. And we'll get the perfect rolling when this instantaneous center is common for all 4 wheels. Okay, when it's common for all 4 wheels. If they don't meet at a point, if all of them don't meet at a point, you won't get perfect rolling. That's a simple logic. But now, over here, if you turn all 4 wheels in a way that the instantaneous center matches at a point where all 4 lines collide over here, then again you would get a perfect rolling, right? To give you a contrary case of this, right? To give you a contrary case of this, let me erase the diagram on the left. Okay. Yeah. So now, if you have, let's say, a turning geometry, something like this, right? And if you are automotive enthusiast, you would know, or if you're Formula One enthusiast, you might know what this geometry is, right? In this case, what I have done basically is I have given the front wheel turning angle of the inner wheel is slightly lesser than the right wheel or the outer wheel, right? Right wheel is moving at a higher angle. And that what would that do is if you extend the center lines over here, they would go apart from each other. They would never meet, right? They would go something like this, right? They would be diverging from each other. They would be diverging from each other. They will never meet. And even at the rear axle, right? The rear 2 points will go at infinity and they will also never meet. Basically, all four wheels now actually there are three different lines: one for the rear wheel, one for the outer wheel, one for the inner wheel on the front, and all three of them are not meeting at a common point. And in this kind of geometry, you won't observe a perfect rolling, right? You won't observe a perfect rolling. Now, the difference between this and this is that over here you have a point which is connecting all four wheels, okay, in the Ackermann geometry. But in case of this geometry, let's not name it, let's not get confused. But right now, what is happening is these two lines are diverging from each other when you come to the rear part of the vehicle, and they're not going to meet. So you're not getting one single point for all four wheels, and that's why the rolling won't be perfect. There will be skid in the wheel. But let's say if you want to get perfect rolling and you want to get shorter turning radius, what we can do is we can keep the Ackermann geometry on the front and we can do a inverse turn on the rear wheels. So basically, these wheels are pointing over here. Let me actually change the color a little bit. Let's say if I take green, yeah. So these two wheels are pointing over here, right? These two wheels are pointing over here, and this creates this kind of motion. It will turn the vehicle like this, right? And now let's imagine, let's see what exactly is happening in the wheels, right? So if I extend these lines something like this over here, it would meet, and again the rear wheels would also meet over here at this point. So this is what is happening over here in this diagram. So right now we got one common point, which is the instantaneous center, right? Which is common for all four wheels. That's why we're getting the perfect rolling. And since we have turned the rear wheels as well, the turning radius has decreased a lot, right? We are getting a sharper turn. We are getting a shorter radius turn. Now this logic is used in Hummer SUV as well, right? And the rear wheels are turnable, and this is actually used in Mercedes S-Class also, and so many vehicles. I'm not even sure what to name right now, right? So even in your commercial, some of your commercial vehicle like Mercedes and BMW's high-end cars, they use this kind of steering. They give a rear wheel steering assist. What they do is they give a limited steering to the rear wheel. In case of Hummer SUV, the rear wheels are allowed to turn by 10 degrees. So if I draw a vertical over here, actually this is not vertical. If I draw a vertical around here, this angle will be less than 10 degrees. The maximum angle that the rear wheel of Hummer wheel could go is 10 degrees, right? And the maximum for the front one might be more than 40 degrees, right? And this, what it does is it assists the wheel to move in such a way that you get one common instantaneous center, which is not lying on the rear axle, but the rear axle is meeting at some shorter distance. Let's say if this was like this, right? If you had to meet the instantaneous center on the rear axle, right? It would take a lot of distance, right? When you compare it with this one, when you compare it with what we have right now, if I extend the rear axle over here, this point would be meeting over here, and this distance is quite a lot, right? When compared to this distance, right? It is very less. So that's how we reduce the turning radius. We get sharper turn, we get perfect rolling, and because of this, you can be sure that your rolling is also perfect because you got the instantaneous center at exactly where you want for all four wheels. Okay, is that clear to everybody? How we move from Ackermann geometry to four-wheel steering, and we use the same principle for perfect rolling. We used the same principle that was used in your Ackermann geometry. Is that clear to everybody? If there are any doubt, please let me know. Okay, is there any doubt? Anybody? Please let me know. Not seeing any doubt in the chat box, but if you have any doubt, please unmute yourself. Okay, I guess there are no more doubts in the session. Anyways, what we'll do, we'll move on. And before I actually move on, I want to ask you guys, like before starting the session, I asked about what do you call crab in your language. And there was somebody, I'm sorry I didn't get your name because I was on the PPT, but there was somebody who called something in Tulu, and I forgot what it was. Could you repeat, please, what exactly it's called in Tulu?
Denji.
Denji, yeah. That's a nice name. That's a nice name. Okay. Anyways, Siddhant and others as well. If you have any doubts or if you didn't understand what exactly this means, how we got four-wheel steering for Ackermann geometry, please let me know. Is it clear to everybody? Jayatit, Ashwin, Pavan, Udayraj, Yash, Chairna, Siddhant, is it clear to everybody?
Yes.
Cool.
Yes,
That's really good to know.
Yes, please.
Cool. So remember this, I'm going to pop a quiz at the end of this session regarding using the four-wheel steering geometry. Okay, now let's move on to how the steering in Hummer works, right? How a Hummer goes into a turn. So this is a Hummer turning on sand. Okay, this is a Hummer vehicle turning on sand, and you can see if I had to draw a center of this turn, it would be somewhere around here. Right? It will be somewhere around here. If I draw a plus sign, that will be better. It will be somewhere around here, right? And the rear wheels are over here. This is one of the, actually, let me use, I'll use probably blue color for it. Yeah. So one wheel is over here at this point. Another wheel is over here at this point. And the front wheels are somewhere around here and here, if I'm not wrong, right? And if I connect the center to the wheel center over here, right? If I connect the instantaneous center to the wheel center, they would look something like this in a Hummer. Okay, it would look something like this, right? And as you can see, it's following our four-wheel steering geometry, right? What we had over here, right? And it's not like the Ackermann geometry. It's not like the Ackermann geometry. It's not like this. The steering center does not lie on the rear axle. Instead, the rear axle, if you extend the rear axle, it would go somewhere around here. But the instantaneous center is over here, which means they're using four-wheel steering geometry. And as you can see, if you look carefully, I don't know if I can zoom this image from here, but let me just try. If you look carefully in this image, and send this to back. Yeah. If you look carefully, you'll find that the wheels are turning. Where the wheels are turning over here, and over here, you'll see slight protuberance right here, right? And that's actually the rear wheel turning. Right, that's actually the rear wheel turning towards the opposite direction. Over here also you can see the front wheel turning. This is the front wheel coming out of the mud guard, and this is the front wheel coming out from the rear. And on this side you can see the rear wheel coming out as well. And that's how a Hummer vehicle turns. It has got the four wheel turning, right? And as you can see, this is what they do in their vehicle. They use this kind of geometry to shorten the turning radius and to achieve sharper turns. Right now, I don't think this is very much complicated when you have understood this part. Right, when you understood the four-wheel steering part, I don't think this is very complicated. Now, moving on to how a crab walk would work. Right. So before I go on to that, now you know how a four-wheel steering works. Now you know how Ackermann geometry works. Could you tell me how would a crab walk work? What would we have to do to achieve the crab walk? Anybody? Please unmute yourself. Okay, so let me recap a little bit. We know what a crab walk is. We want to achieve that motion. We want the diagonal motion of the vehicle. We know how a normal steering works. We know Hummer is not using a normal steering. We know how four-wheel steering works, and we know how Hummer is using a four-wheel steering. Now, I want you guys to try to imagine how a crab walk would work, or how would you implement crab walk in a Hummer SUV if you have these facilities, if you have this knowledge of Ackermann geometry and the four-wheel steering geometry. Okay, anybody would like to give it a try? Siddhant, Jayana, Ashwin, anybody who would like to give it a try? And we have people who are completely silent in this session. I would like to encourage you as well. Okay. All wheels turning in the same direction. That's a really good answer. Amarjeet, and it was, I guess, from Himanshu, all wheel turning in the same direction. That's really good to know. And what would be the uh, the motion that you would get if you have all wheels turning in the same direction? And also, if all of the wheels are turning in the same direction, would you need to turn them in the same angle? Is my question.
Wheels will slightly be turning with less degree than the front one.
Okay, and that would help you that would actually turn the vehicle, no? Because that's what we saw. Right, let's imagine this
No,
scenario
in the same direction.
in the same direction. Let's imagine the scenario. What will happen? Okay, so let's say if I have this front wheel, okay, they are turning in this direction like this, and let's say if you have a rear wheels which are turning slightly less, okay, something like this, right, slightly less. Now, in this case, the vehicle will go in this direction. That's what you're saying, correct?
Yes.
Correct? Yes. Yeah. Now let's analyze this. Actually, I'll change the color into black so that it's understandable. Now this wheel is pulling the vehicle in this direction. Correct? It's always going to be the point where the wheel is facing. This wheel is going to push in this direction. Let's say these two are parallel. The black lines are parallel, and let's say the green lines are now parallel. Okay, but the black lines and the green lines are not parallel. Okay, now in this case, two of the wheels are pulling it in the direction this way, and the the two wheels which are parallel to each other on the rear are pulling it in some other direction. So basically, these wheels are pushing it slightly forward and slightly towards the left, whereas this wheel is pushing it highly towards the left and slightly forward. Correct? If I'm not wrong, is what is happening? Yes.
Yes, sir.
Yes. And in this case, what do you think the net result would be out this?
So diagonal turning.
Car
I
will
guess.
not remain in.
Okay. The tire will not remain. Someone had left it incomplete. Could you please complete that first?
Oversteer.
Oversteer.
Would there be any slip of the tire in such imbalanced force?
Correct. Correct. What kind of imbalance would we face over here?
Because now
What kind of forces?
you have shown vector horizontal, vertical, which would superimpose. Resultant force has to act somewhere.
Correct.
Where does it act? Either on the body of the vehicle or on the tire. Somewhere this resultant force has to act on the somewhere, no?
Correct. So this force is actually, if you think about it, this is the force the ground is giving back to us. Right? That's why the vehicle is going to move in that way. To better explain this, if we have a tire in this way, right? And if you want to go in this direction, the tire will rotate in this direction, right, clockwise. The tire will push the ground behind, right? And the ground will give a reaction force. Just understanding the basic of it, the ground will give the reaction force in the direction of the desired direction, right? In the direction of the desired motion. And that's why you go in the front, because the ground is giving you the force on the wheel to move front, right? So these forces that we calculate, that we've drawn, or that we have sketched over here, are actually the force that the ground is giving on the wheels, right? So the ground is going to push the wheel in this direction. Now imagining what your wheels will do to the ground. So the wheels basically, so if I draw a resultant of it, this one is going to be something like this. Actually, not like this. It's going to be inclined more, somewhere around like this. It's going to be something like this, right? And this resultant may be something like this, right? Now, this is the motion that the ground is pushing the wheels in the direction, right? This is the motion where this is the force that the wheels are getting from the ground, right? Now, opposite of this, the wheel should push the vehicle. Wheel should push the ground. So if I talk about the wheel pushing the ground, again using the same analogy as this one, I'll draw it in two. This should be in this direction. The wheel should push the ground in this direction, and over here it should move like this. It should move like this, right? Now let's imagine the front wheels are getting more of us because over here the front wheels are getting more sideways motion than the rear wheel. Is that true? Everybody agrees with me on this? Yes, you had suggested this sketch. Do you agree with me?
Yes, sir. Yes.
All right, and you are saying because of this you'll get the crab walk motion that is there.
Yes, sir.
Okay. So let's go back to the video once and check if Yash is right. Okay, so as you can see, the entire vehicle remains as it is, stable as it is. It does not move, right? Initially, as you see here, the turning takes place and then he moves into the crab walk. But when he's coming back, the entire thing goes into the crab walk and you can see the vehicle moving just in crab walk, right? So now, if you think about it, every time they are switching the direction for the crab walk, the vehicle first turns a little bit, right? It's not as it is in the front direction, right? It will turn a little bit and then move into a crab walk. If you see, it's slightly turning and then going into a crab walk. So yes, you're absolutely right. When we do this kind of turn in crab walk, what we do is initially we keep this model. Okay, the front wheels are turning more than the rear wheels, but when it becomes stable, when it's already in motion, in that case, all the wheels are turned in equal direction, which means the black line and the green line, these two lines, become parallel to each other, or these four lines rather become parallel to each other, and that's how we get to the crab walk. Okay. Now, is that clear to everyone? First of all, how the crab walk works?
So that all the wheels are in the same degree of turn,
All the
right?
same, yeah. All the wheels are in the same degree of turn. So that once you start turning, right, once it's in turn, it becomes stable at some point, and then it could move like this. So even when we are watching the video, right, in this video, as you can see, let me actually go to the video. Yeah. In the video also they're first turning slightly and then going to the crab walk motion. So as you can see, actually not in this one, but yeah, on the front view, yeah, they're turning slightly and then they're going to the crab walk motion. And when they turn in the opposite direction, you'll see they're turning first slightly, and then going into the crab walk motion. So this is what is happening in Hummer SUV. So first we make it stable so that it does not go out of balance, and then we approach the crab walk.
So is this possible in this so that the rear wheels can maintain the opposite direction of the front wheel, like the other vehicles do?
Could you repeat that, please, somebody?
Yeah, sure. In this like crab walk thing, can the rear wheels maintain the different direction of rotation as the Mercedes and Audi do, like their in order to compensate the radius of
Correct. So that becomes a four-wheel steering, in that case.
yeah, can we maintain that?
Yeah. So,
But
see,
can we accomplish both the things in the same mechanism? Is it possible?
yeah, it is happening in the same mechanism. The Hummer SUV is also got the four-wheel steering, right, like we discussed, and it's got the crab walk. It's happening in the same mechanism. But what you're asking is because see, at the time of crab walk, all the wheels are pointing in one direction. Although they might not be parallel in the beginning, but later on they become parallel and they're pointing in one direction. But if you're applying it for the four-wheel steering, in that case, your front wheels are pointing like this and your rear wheels are pointing like this. And this creates the turning motion.
Yeah. The
Yeah.
same thing. Is that possible? Like any mechanism is there, like or any software issues? I mean, software we can achieve that.
On software.
Yeah.
Okay, I don't know if there are any simulations, or maybe on Adams you can do this. Any kind of mechanical kinematic software, I guess you can do this. But I'm not too sure. I haven't used this, so I'm not sure. But I guess it can be done.
Okay.
Yeah, and Kushal is asking, can this be achieved at high speeds? Kushal, what do you think would happen at high speed? It might drift. Why? And you can unmute yourself if that's possible, Kushal. That would be really great.
So due to high speeds, I believe that it will take a bit of a drift. While if, for example, if you are overtaking someone, like real time example, so at a high speed more than 100, so it will drift now while going to the diagonal direction, or it will go smoothly. It can be achieved.
Okay, so there are a few things happening right here, right? So let's imagine what we have seen till now is the vehicle was stationary, and then it moved slightly like this. It turned slightly, and then it went to a climb, right? And then it would turn slightly and then go into a crash. That's what we learned till now. But if you want to do it on the go, you are at 100 km/h already, and you suddenly do a crab walk, right? And you slowly do a crab walk. First of all, tell me what would happen if you turn your steering wheel at 100 km/h.
So
It will roll.
It will drift.
Good answer. Before drifting, it would actually roll, and then it would become unstable, right? And
right.
why we are turning the vehicle in the beginning? What do you think? Why we are turning the vehicle in the beginning and then going into a crab walk?
So that it should get stable.
Correct, because it should not destabilize, it should not roll, and it should not drift, right? So because it's to avoid the rolling motion, we are using at low speeds. We are first turning and then going into a crab walk. At higher speeds, even if we turn, we are going to get the roll motion, right? And if we introduce crab walk, it's going to get a higher roll, and it's going to be super destabilized.
Destructive.
Yeah, and yeah, destructive. So basically, I don't think it can be applicable for high speed application. And Hummer SUV is not actually made for high speed application. It's a SUV which is more of a off-roading kind of thing.
Rigid.
Yeah, for those kind of applications. So I don't think it can be used for high speeds, and that is why Hummer SUV it is involved in Hummer SUV, because SUV is not a high speed application.
Do you mean to say this at high speed, maybe this inertia, everything gets multiplied? Stability is one of the more problem.
Correct, definitely, because the vehicle wants to go in the straight direction, right? Because of the inertia. Now,
Is it maybe for a heavy duty vehicles? The safety requirement is also required for heavy duty vehicle. How do we define? Where do we need this type of technology, and which type of vehicles we need this type of box technology?
so you're asking which type of vehicle we would need this kind of technology.
Yes.
Okay, so right now, I don't think we can apply it anywhere else apart from your common SUVs, right? Because basically, you need slow speed application. You don't need. Hello.
Sir, is would be better when we are in high speed, we
No,
are
it won't
turning.
be better. It won't be better because it will be highly unstable.
That's
Very,
what I was
very,
asking. In
very,
in the case of slow speed, it is better.
In case of standstill, it is better. Right?
Yes,
Where your vehicle is standing still, you take it a little bit like this and then go over here. Without
yes,
gaining much speed, you turn it around here and then go over here. That's the basics of it. You don't want to go at higher speeds. And
if
I would recommend people to wait a while, because I'm going to share the form link for certificate and a free counseling session. So wait around for that. If you leave the meeting, you might not get the certificate.
the actual motion of crab is in the second case.
The actual motion of crab is actually
The second case,
horizontal, sideways. It goes
yes, sir.
sideways. If you talk about the
According to my imagination, the crab moves the same
correct,
like that only. If in the first case, it will take more angle
correct,
in turning.
correct,
Actual moment of crab is in the second motion.
correct. It's
Horizontal.
actually in the horizontal
Yeah.
motion. It is not even in the front direction. It's just sideways.
Yes, sir.
Okay, so before we conclude, I would like to know your thoughts on how this can be, work. This can be used for future development. What do you think we can do for future development?
of course, these are again either through the linkage mechanism or compound springs, inner spring, outer spring.
Jana, your voice is cracking. Could you repeat, please?
Is it through the linkage mechanism or springs in action mechanism?
Okay, for the mechanism part of it, Hamar SUV is not revealed yet how they do it. But what I think is there's going to be individual motors controlling the steering part of each wheel, and that is why they get into whatever motion they would like to keep it. If you use a mechanism and spring or any kind of linkages, it would be difficult to change from four-wheel steering to crab walk, and you like to we would have to add probably another mechanism for changing between these two. So they have probably done it electrically by giving different electric motors for four wheels, and that's how they by using a ECU by controlling the angle by which the motors allow the wheels to turn. They have gotten the perfect ruling for that as well. That is what I think, but they haven't released it, so I don't know if they use a mechanism. But I'm pretty sure they don't use a mechanism.
Which are the automobile manufacturers or vehicle manufacturers started this technology? Any papers? Any paper publications?
You might find the paper for the Hummer SUV as well, or crab walk technology. There are a lot of crab walk technologies. The manufacturer is actually GMC. So I'll write the name of the vehicle and the manufacturer in the chat box for your reference.
Maybe I am of the opinion with the latest technologies, this sensor, laser techniques, automatic giving something that may be much safer than any mechanical systems which will depend little because
Jana, could you repeat? I'm not able to hear you. Sorry.
I am really not able to catch up this technology, how things can be implemented, Mr. Sheikh. Maybe
Okay,
it may
from
be
the mechanism point of view.
it is definitely is a good way of understanding and analysis requirement. How do they do and how do they implement? Maybe we have to wait and see.
Okay, so what I think they do is they put motors on the knuckle. They put small mechanisms with motors and gears on knuckle itself, and with their ECU, with their sensors, they give the motor rotation, the rotation of the wheel at a certain angle. So instead of you turning your steering wheel and then the mechanism pushing a rack and pinion and tie rod and Ackerman arm, they have a system that senses your steering wheel motion, and according to that motion, it will turn the rotational wheel, the road wheels at some angle in some speed. Okay, and this
Already electronic ESP are there,
correct,
electronic stable
correct.
programming. Maybe that we
That's what
in
yeah,
the
that's what we
in
are doing.
they may adapt to some of these things. ESP, electronic stability program systems.
Correct. So I think that's what they do, and I'm pretty sure that's what they do. I'm eager to know what exactly they do since they haven't released the
Probably
official.
you have to see advanced ESPs from the vast electronic stability program devices. They are not fully implemented for Indian vehicle. Maybe step by steps because as it is a vehicle, once a stability program is implemented by the government, people also start adopting
Correct,
these.
correct, correct, correct. Yeah, and if it's one of the BS norms, it would definitely come into play. Okay.
Very nice state. Good thinking, I think, good useful information. Maybe we can also share during some of our interactions with an experts.
Right. So I've actually put the form link for everybody in the chat box. This form is for your certification of this bootcamp and also to get a free counseling from Elite Techno Groups. Our counselors will guide you to according to your needs, what